This is the homework for 5.6, 5.7, 5.8, and 5.10a. For problem 5.6, we need to assume the growth rate of the rabbits multiplies as it did in problem 5.1. Now we need to complete each of the tables. So if you look at the months to rabbits, in month 0, when it started, your initial value, you had 4 rabbits. In each month, it increased by 3 times the amount. So we have 4 times 3 is 12, and it's at a constant rate. 12 times 3 is 36. 36 times 3 is 108. 108 multiplied by 3 is 324. So it's increasing by 3 times for each month. There's also an equation that you can use for this growth, and we have y is the total, a is the initial value, what you start with. We're starting with 4. B is the growth rate. What is it increasing by? It's 3 times. And x, the exponent, is the number of months. So we can use this. Initial value is 4 rabbits. And for 3 months, it's increasing by multiplying by 3 in the exponent. And if we want to find for the 4th month, 3 to the 4th power is 81. 4 multiplied by 81 is 324. And you could use this for any number of rabbits or any number of months. For problem B, we need to find the growth rate. And we have 6 and 24, but this one was missing. Well, you know that this is increasing by 2 months, and this is 4 times. 6 times 4 is 24. Well, if we divide this by 2, if we take half of it, and we only increase it by 2, multiply by 2, 6 times 12 is 2. Because halfway from 2, half of 2 is 1, half of 24 is 12. And now we know the growth rate. It's growing, multiplying by 2 for every 1 month. And we can use the equation that we had in the previous problem. A represents the initial value, B is the growth rate, and X represents the number of months. So this is, the growth rate is times 2. And for 1 month, 2 to the 1st power is 2. 2 times 6 is 12. We can use it for the 3rd month. So it's to the 3rd power. Growth rate is the same, multiplied by 2. Order of operations, we have to do exponents first. 2 to the 3rd power is 2 times 2 is 4, times 2 is 8. 6 times 8 is 48, and that's what we got for the 3rd month. For 5.7a, we need to plot the points 3, -1. So here's 3, -1, 3, 2, and 3, 4. And draw a line that passes through them. So here's my line. And now we need to state coordinates of 2 more points on that line. So any points on this line could be used. For example, 3, 0 would be here. That's on that line. 3, -3 would be here. So any 2 points on this line would work. You could do 3, -1.5. So as long as it falls along this line, that would work. Now we have to come up with the equation, and the equation of this line is x equals 3. And I had written it on here because any value of y, the x is going to be 3. For part B, we need to plot the points 5, -1, so 5 on the x, -1 on the y, 1 on the x, -1 on the y, and -3 on the x, and -1 on the y. For this, what is the equation that goes through? Well, for this one, it was positive 3 on the x-axis. And you can see right here, if I go 3 on the x-axis, and I put a little hash mark, that's telling you that this vertical line is x equals 3. Well, this line happens to be on the y-axis. So if I go down and I put a little hash mark here, you can see that this is a horizontal line that's going across. And this gives us the equation of y equals -1. For part C, choose any 3 points on the y-axis. So here is the y-axis. And now what is the equation of this line that goes through these points? So here are 3 points I have chosen. Well, this line is going through the x-axis, and if I put here, this has the equation of this line is x equals 0, because all the points on this line will have an x-coordinate of 0, and we're not going anywhere on the x-axis. So this would be 0, 1, 0, 3, and then this point would be 0 on the x, -3 on the y. Problem 5.8. What number is not part of the domain of the function g of x equals x plus 2 over x minus 1? Well, remember, domain represents all possible x values. So what values can we replace x with? Well, in order to do that, if you remember that when you have a denominator, the denominator cannot equal 0. And the reason why, for example, here, 3 over 0, if the denominator is 0, that's saying I have 3 groups of nothing. So I can't have 3 of nothing. So this is called, undefined. So if we can't have a denominator of 0, what I do is to determine which x values are not possible, I set this denominator to 0. And that would look like this. X minus 1 equals 0. And again, if I say this denominator equals 0, well, that can't happen because we determine a denominator with 0 is undefined. So now I solve for x. Inverse property of subtraction is addition. So I'm adding 1 to both sides. It creates a 0 pair. 0 plus 1 is 1. So x cannot equal 1, because if I put 1 in here, 1 minus 1 equals 0. And that would make this function undefined. So 1 is not part of the domain. The domain would be all real numbers except 1. For 10a, we're going to plot triangle ABC on the graph with the points 1, 1 for A, B, -1, -1, and C, 4, -1. So now we're going to use the function x to -x and y to positive y, or positive y to y. It could also look like this, xy to -x, positive y. So we're transforming this. So you can see that the y values are staying the same. The x values are becoming its opposite. So here we have 1, the opposite of positive 1 is going to be -1. And then the y is going to stay the same. Opposite of -1, positive 1. Opposite of positive 4, -4, and the y's stay the same. And when I plot these points, which transformation did we create? Well, this is a reflection. You can see that each A to A prime are equidistant. C to C prime are both equidistant from the line of reflection, which is the y-axis. So the type of transformation is a reflection across the y-axis.